So this is just an informal walkthrough of the simple potato gun launcher that we've created on CADWolf. We're going to start by looking at the workspace that houses these designs. There's the introductory document that gives you some parameters, the part tree, and the workflow, and then just a folder to hold some of our images. As you can see, this is based off of a WikiHow that we've linked to. The WikiHow just shows you how to put it together. Gives you some good introductory tips on how to do that. Our design is slightly different because we wanted to make sure that all the items that the gun is made out of could be bought at a hardware store. So partly so we'd have the dimensions readily available, but partly just so we weren't just making something up, and you could actually build this gun by yourself if you wanted to. Alright, so that link is in our description. Let's go over to our Onshape model. This is a really simple item to design. We've inserted a plane here, and we'll go ahead and cut this in half by viewing by this surface. And in Onshape, that's pretty simple to do. You've just got this surface here, you brought it into your assembly, you go to the view icon at the bottom there, you'll see the proper tab to view a cross-sectional view. So we'll click on that. Nope, I guess I didn't click on that. There we go. So this arrow will let you pull back and forth as to how far back and forth from that surface you're actually slicing into the model. Alright, so let's go ahead and set it at the center. And our design is pretty simple. You've got the barrel there at the end. At the opposite end, you've got the end cap, which screws on and off. You unscrew it, insert the propellant, spray the hairspray in, and then spray it back on. See, click on this right there. You can see that it's threaded on both ends. There's that gray adapter that connects the combustion chamber to the end cap. The combustion chamber is in the light brown, the end cap's in the orange. We've got a hole in the combustion chamber for the firing mechanism, and there would be wires hanging down there normally. This is our reducer. It's the green part there that connects the combustion chamber to the barrel. And these are just glued on, so you don't see any threads there. PVC glue is actually pretty strong. Excuse me, strong. Shouldn't have a problem connecting the items as long as you let it dry. It's not going to be a problem. All right, so let's go ahead and take away our cross-sectional view, rehide that plane, and we'll go back to look at some of these individual parts. Now, as you can see, that we've got that square on there to help you screw it in. These are all store-bought parts. You could go to any Home Depot or something and buy this PVC pipe and then just saw it to the length you want. So in Onshape, we've got our different part studios. The parts are designed in those studios, and then we've got our assembly that houses them all. So we'll go over to the combustion chamber. It's just a simple tube. There's the hole for the wires to go through. So we've added some equations at the top here. When Onshape builds a model, it builds top to bottom here. So you want to have those variables at the top there, because what we've done is we made the sketch the inner and outer radius, or these set to these parameters here, these variables. And when we did the extrude, we set it to that length of that chamber there. And as long as you use the hashtag, it picks up on it being a variable. So those variables have to be above where you're calling them in that design for them to work. This is going to be significant in a minute because we're going to show how we send these variables to Onshape from CADWolf. That's just a closer look at the end cap, so you can see that it's threaded. It's got the notch at the end. Alright, so there's the model again. Let's put it to isometric. And let's go over and take a look. Start back in the workspace. So there's a simple document. There's not a lot of math involved with this. It's just simple design parameters. We're going to look closer at the part tree in a second, and then the workflow. Let's go look at the introductory document. As you see, like I said, there's not a lot of math here. We just describe the basic design, give some still screen captures. And at the bottom, you'll see we set the density of the PVC. That's the only item that's going to be pulled into the other documents and used. If you were doing some heavier calculations, you might have one or more design documents where you set parameters that are pulled in, like factors of safety, that sort of thing. So in our part tree, you can see we've got a separate document for each one of our parts. And let's go ahead, and we've linked these all to the CAD. So as long as you're logged on to Onshape, and these have been set up, which we have. The icons for them will show, and we'll be able to pull in those CAD properties, as we'll see here in a second. The combustion chamber is one. We've set it to there's one of them. And we'll go take a look at that document. All right, so again, very simple. There's no math. We just simply set to the variables here. As you can see, they've got the same names as the ones that are in the Onshape document. That's obviously extremely important, because the way this works is we simply send these variable names to those Onshape documents and elements. We then calculate the mass and weight. Those are the only calculations in this item. So here's our windows over here to the left. As you can see, we're importing PVC density from that main document. The way we did that was we simply looked at the path of that document. We're in the projects workspace, hit enter. It gives you all those folders. Then you, I clicked it twice, okay. So we'll delete that in the shooters. And there is our part tree, and there is our design documents that we have. So click on it, it says those are the variables there. In that document available, there's only the one, so we've got it set up that way. All right, so like I said, we calculated the mass and the weight based on the rated diameters and the lengths. So we'll go back to the part tree. And as you saw, the name of that variable was weight. So we've done that in every document, so we can enter the weight variable there and it pulls it back out. We can also pull those items from our CAD models, and they should sync up. And oh, that one for the coupler is off. I was playing with these earlier and changed them around, so the CAD model might not be completely up to date with the document, and that was the case there. So that button on the left that I clicked to update all masses just repulls them from the CAD model. All right, so as you can see, it's up to date there. Everything matches up between the CAD and our actual calculated values. So let's just go back in that combustion chamber document, and let's just say instead of having a length of the combustion chamber that was 2 feet, that's 24 inches, let's set that to say half of that, 12 inches. Hit enter. There, see the mass and the weight recalculate themselves automatically. We hit the save button. This will sometimes take a few seconds if you're sending a lot of parameters to Onshape, because you're waiting for them to get that response to Onshape to show that everything was okay. So there we go. So you saw as soon as we clicked over it, it was already updated. The length of it was cut in half. So any variables that were affected by that redesign would have updated also. We'll go back to the parts review and you'll see this. All right, so we'll re-enter the weight. And as you see, that value is less than it was before. So there it was before. It still hasn't updated in the CAD, or we haven't pulled the updated values from the CAD model. So we'll pull those, and as soon as we get the response from the Onshape models, it looks to be matching up. All right, so that's a basic introduction to how a redesign would work. If we had changed the diameter of that combustion chamber, you see this red here, it means that it's basically telling us, hey, these items depend upon something from that file, and that file has been changed, therefore you need to update these files, which you can do from here. But I know, obviously, from designing this, that if I change the diameter, then I would have to go back and update these other related components. But since I just changed the length of that chamber, it's not important. Looking quickly at the workflow, you can see that the save icons show you when it's saved. You can go in and change this to see when things weren't saved or created. So this is just the createds now. It's a little bit cleaner to look at. The events all apply to all, so they cross all of them. You can click on it and get a brief description of what that event was. So basically, we've just created an event to show, hey, this is when we designed it, this is when we did the testing, this is when we built it. There's a little gray event there for barrel redesign. You can add new events there if you've got edit permissions. This will look different if you don't have edit permissions, but I just wanted to show you what it looks like when you have edit permissions. You can assign these events to all items or to specific items. You can give sign-off, create roles, and assign certain people. All this is available in the workflow documentation. I just wanted to show basically how this works, that you've got some events, you apply them to certain things. This helps you keep track of who's doing what and what's been done to what item. And that's basically it for the workflow. This is a pretty simple design. There's not a lot going on with it, so we'll leave it at that. Take a look at the other projects if you want to get into something more complicated.